Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the second question on the try playlist, which is implement try part 2. Now what does this question state? In the previous question we did learn about how to insert, how to search and how to check if there is someone who exists with the same prefix or not. Now if you haven't seen that video, please don't watch this video because this is an extension of the previous one, so you'll not understand anything. Please make sure you watch that video at first, then you can start off with this one. So what does the question states? The question is pretty much similar. It says that you'll be given a constructor which creates a try for itself, and then you'll be asked to insert a word. You'll be given a word, you have to store it, then you'll be asked count words equal to. Now in the previous question we were like, you have to tell if there exists or not. In this question you have to tell how many exist. Okay, you have to tell how many exist. Now coming across count words starting with prefix. Now you in the previous question said if there exists someone who is starting with the same prefix. Now this time around you have to tell how many are there that start with the same prefix. So this is how the question is, and there's one more change where they say, hey listen, you have to erase the given word. So there are 4 functionalities that you have to implement. One is insert, the next one is count words equal to, the next one is count words starting with, and the next one is erase. So let's check this out. How will we do this? So let's check this example. They're saying insert Samsung twice, insert Vivo, erase Vivo. Now count words equal to Samsung. Samsung does exist twice, so 2. Count words starting with VI. Now had you not erased Vivo, then there would have been 2 guys who are starting with VI. But since you have erased, it will be 0. So this is how you have to implement your try such that these functionalities are performed. So let's try out the first functionality, that is insert functionality. And I'm giving you these 4 words that you have to insert. Now how's this question different from the first one? In the first one you have to tell if there exist. Over here you have to say how many exist. So you have to, like your brain works, right? You have to count. So what we will do is, we will declare a try over here, similar to the previous one, where we will be containing the links of 26 characters. But instead of having a flag which told us, hey listen, true, means there does exist a word. Instead of that, we will have a variable end with equal to 0 and count prefix as 0. Now these are integer variables which are gonna count and end, and we will initially declare a root, okay, and the end with will be 0 and the count prefix will be 0 of this root. This is the initial try that is declared, which has count end with and count prefix. Okay, it also has 26 links. As of now there are none of the links are valid, so you can say it's null. All the links are null. Now let's start off with the first one and try to insert it. Apple, A for the first. A is the first one. Now let's see if A, initially we start here, does A exist? No. So insert A and have it point to a new try. Insert A and have it point to a new try which says end with 0. It's not ending here, but the count prefix is 1 over here. Remember, A is pointing to a try. A is pointing to a try which will have end with as 0 and count prefix as 1 because there is a word that starts with A. For sure. Perfect. Next, you will come to this try. Yes, you will come to this try. Now you are standing at this try when you come to P. Now when you come to P, does it have a P? No. So please make sure you insert a P and you create a corresponding try for that. Yes, you create a corresponding try for that with end with as 0 and count prefix as 1. Just make sure. Now what you do is, you were here, now you will come here. So now you are standing here and you are at the next P. Does it have a P? No. Please insert a P and make sure it is pointing to a new try which will have end with as 0, count prefix as 1. Perfect. Now you are standing at this try and you are at L. Does it have an L? No. Please insert an L. So you will insert an L and this will now point to a prefix, this will now point to a try whose end with will be 0 and count prefix will be 1. Perfect. Now you'll come and stand over here. Now you'll come and stand over here. Okay. So you are done with L. Now you are having E. So let's have E. Do you have E? No. So please insert E, and for that have a new try. Now when you're having a new try, this is having end width as 0, CP as 1, because there does exist a word which starts with apple, but you have inserted every one. So can I say that's the end of the word? And if it is the end of the word, you're standing at this try, the last word, yes, you'll go over there and you'll say, hey listen, you're the last word, right? So end with 1 and count prefix stays as 1. So I'm saying end with will be incremented to 1. End with will be incremented to 1. That is what I'm saying to you. Absolutely makes sense. So apple has been inserted. Okay. Next time. So we are done with the first insertion. Let's come to the next insertion, which is apple. Now again, you start with the root of the tree. What are you looking for? A. Yes, we have an A. Whose A's try? This one. So there is a word that starts with A. So just make sure you increase that. Right? You are standing here. A is done. Now go to P. That means you just change the try. You go to the next one. Perfect. You are standing here and you are at P. Does P exist? Yes, P exists. Whose P's try? This one. Please increase. Perfect. Now you are standing over here. Does this P exist? Yes. Yes. Who's this P's try? This. Increase the count prefix. Perfect. Next. You are standing at here. Does L exist? Yes. Who's L's try? Here. Increase the prefix. Perfect. I hope you are understanding why am I increasing the prefix. Because we know that there does exist a word which starts with A. AP, APP, APPL, APPLE. Correct? Next. Where are you? You are over here. Correct? You are having E. Yes, E exists. Who's E's try? This one. Please go and change this to 2. Correct? Now, can I say the word is completed? And if the word is completed, where are you standing at the end? Here. And if you're standing here at the end, what you'll do is, you will say, there's one more that ends with E. Perfect. So if you see carefully, I have made sure all the prefixes are 2. So if someone asks how many does start with APP, you'll always get APP, and that's a 2. You'll always get that. Let's check this out again. Let's check the next word. APPS. Again, you're standing over here. Does A exist? Yes. Who's the prefix? This one. Increase. Next, you're standing here. Does P exist? Yes. Who's the try? Increase. Next, you're standing here. Does P exist? Yes. Who's the prefix? This one. Increase. Next, you're standing here. Does S exist? Does S exist? No, no, no. So that's the moment. That's the moment you'll say, I will insert an S and I'll create a try for that. I'll insert an S and I'll create a try for that with end with as 0 and count prefix as 1. Because there is someone, yes, this S try is this. There is someone who is ending with, there's someone with S, so count prefix as 1. Now I can say, this word has been completely inserted. So it ends with S. It ends with S. SS try is this one. So make sure this guy has been changed to 1. Ending with will be changed to 1. Perfect. Next, again APPS. Let's see this out. Now when we are at APPS, initially we are at the root. Yes, initially we are at the root. Now if we are at the root, what will you do? You have an A. Yes, exists. This A's try is this one. Increase. Perfect. Does P exist? Yes, exist. P's try is this one. Increase. Perfect. Next, where are you standing at? Over here. Does this P exist? Yes. This try is this one. Please increase. Does S exist? Yes. S exists. And if S exists, who's the try? This one. Please make sure change the count prefix to 2. And if there's one more word that ends with S, so count and also ends with, you increase that to 2. It's very simple. On the flow, for every word's try, you increase the count prefix. And whenever you're ending at, for that try, you increase the count end. That is what you will do. Perfect. So we have specifically done the insert operation. Now count words end. Like how many words are ending with? How do you count? How many words are ending with apps? Or how many words are ending with ABC? Okay, let's take these two examples and check this out. So we have initially apps, and I have to tell how many words are there that ends with apps. Initially you stand with root. Do you have A? You have. That's the try. Perfect. Please move to the try. Do you have P? Yes. Who's the try? Here. Please move to that. Next. You have P. Yes. Who's the try? Move. Next you have S. Who's the try? This one. Move to here. You are ending. You have done with apps. You are standing here. How many are ending? How many are ending? 2. So you can easily say, since you ended at this try, there are 2 words that are ending with apps. So the answer to this will be 2. Perfect. Next, A, B, C. Does A exist? Yes. Who's the try? This one. From here, you'll go here. Does B exist? No, no. If B does not exist, you will say, hey dude, go back. There's no one that ends with this. There's no one that ends with this. Perfect. Let's do the next portion. Count words start with. Yes, count words start with. So if I'm saying how many starts with AP, you're initially starting with root. Does A exist? Yes. This is the try. Okay. I move here. What's the next? Does P exist? Yes. We move here. We are almost done with this. We are done with AP. How many? For this P, what's the value? 4. So there are 4 words that starts with AP. There are 4 words that starts with AP because for A, this is the reference. For P, this is the try. In this try, they're saying there are 4 words that ends with this particular P because for this P, this is the try. You need to understand this. Perfect. Apple. Similarly, you'll say A, P, P, L. So for this L, which is the try, here. In this try, there are 2. There are 2. Because L is here. For this L, this is the try. And here's the 2. So you can say there are 2 guys that ends with APPL. That's how you do it. Now there's one more function that remains, which is nothing but, I'll just change the color. That is nothing but the erase function. When they say erase a particular word. Okay. For an example, I say, hey, can you please erase the word apps? Can you please erase the word apps? APPS. Can you please do it for me? I'll be like, okay, let's try that out. How do you do this? Very simple, yeah. It's the opposite. Reduce, reduce. Yeah. Where are you? Where is A? For this A, where is A? Here. Where's the prefix? Reduce. Where's P? Here. For this, which is the try? This one. Reduce. For this P, which is the try? This is the P. And for this P, this is the try. Reduce. Where's S? Here. Which is the try? This one. Reduce. So at the end you can say APPS is done. At the end you can say APPS is done. Once APPS is done, you have reached the end. Reduce the words that end with, because currently you're standing at APPS. Is exactly the opposite. You move on the try and you reduce. Now you might ask, will the nodes be deleted? No, you cannot delete the node and there will be a problem. But yeah, what we can do is we can simply say that, hey listen, if by chance the count prefixes become 0, then you can think of a delete. But yeah, I'll not do that because we just need to count. So if you just make the count reduce, I think that should work. There's no need to delete the links. If you just delete the counts, I think that will make our job easy. So guys, this is how you can easily do it. Like, it's very straightforward, very simple. Like, you just need to maintain end with and count prefix and you should be able to do it. So I'll be discussing the C++ as well as the Java code. Now in tries, I am actually typing the code so that it gives you much more clarity. So I'll type the C++ code. It's exactly equivalent to Java code. Like, it's just for loop, arrays. So for that reason, what I've done is I've kept the similar Java code on the right so that you guys can follow the Java code just in case you are not able to connect. That will be very easy, right? So this is how the question will be given. It will be given 4 functions. one is the constructor, and the 4 other functions will be this. So as usual, what we will do is we will create the try. Yes, we will create the node for us. Now in the node, what we will do is we will just create the links of 26 size. Okay, and we will keep count end width equal to 0, and we will keep count prefix equal to 0. Okay, and if you remember well, the functions that we need is boolean contains key, bool contains key. So let's write boolean contains key, and we give the character ch, and we simply say return.
Sorry, I can't.
Next, we will be requiring the get in order to get this guy's try. So link ch minus a will give this guy's try. What's the other thing that I need? I need to make sure that if there does not exist the character, then I'll have to give him the node in order to insert it. So I'll just give him the node, which is this, and yeah, in this way this will be taken. Now the other things that I'll be requiring is the increase end. Like whenever I reach the end, I need to increase the end. So count end with plus plus will increase. That's very simple. The other thing that I'll be requiring is increase the prefix every time I do. So let's write the increase prefix. That's again count prefix plus plus. What's the other thing that I'll be requiring? I'll be requiring something like delete end. Now this is very simple. When you do the opposite, which is count end with minus minus, and then you require void reduce prefix. It's a similar one. I just added some other functions. This is how the struct will look like. The classes on the right and the struct almost similar. Now what we will do is we will go across and create it. Now as usual, we always require something which is known as our root of the trie rather. So what we will do is we will say, okay, let's create the root of the trie, which is node star root, and in the constructor, let's do one thing. Whenever the constructor is called, let's create a new object for that struct, so that for every object call, there's a new trie that is given to them. Okay, now over here we have to insert it. So if you remember properly, we always took up a node which is initially standing at the root, correct? And then we iterated on the word that is given to us. So let's iterate quickly on the word that's given to us. That's something like this. And what we will say is, okay, now what do we require? If the node, yes, if the node does not contains this particular word I, that means it is not there, right? In that case, I'll say node, can you please put across this word I with a new node. That means a reference node will be put across. Now once you have put across the reference node, can I say that, okay, you have put across the reference node for a particular guy. Now can you go across to that guy, which is again very simple. You will just be saying just go across to that try. Once you have gone to that try, can I say, you will simply say, okay, that try, can you increase the prefix, because there is a guy with the same prefix plus plus. Can you increase the prefix? I'll be like, okay, I am perfect, so please increase the prefix. So he's increasing the prefix. Once you've done the entire stuff, whenever you're at the end, can I say, if you're at the end, can you say, can you please increase my end? I think I can. So since I wrote down all these functions, it becomes much more readable. I'm saying increase prefix, increase end, put does not contains. So this is how you can write the insert. Quite simple. Count words equal to. Again, a very simple one. Again, if I just write this one on the parallel, it's kind of like you take a node initially with the node equal to root. And what you do is you go across 0, and then you are like, let's go across to the size, and then do an I plus plus, and then what you do is if the node contains this key, which is something like this, word I, then it's perfect. Then it's absolutely perfect. Let's go to that word I. If it contains, and if it does not contains, then can you please return a 0 saying, hey, listen, there's no one with that. And if you are going like going like apple, A, P, P, L, E, then when you're reaching the end, you just need the get, like how many ends are there? Have we written the get end? I think we have missed the get end over here. Okay, we will just be adding these two functions. Yeah, we'll just be adding these two functions so we can easily get end. Yes. So node, you'll say get end, whatever is the value, how many values are there at the end, just get it, and you will be like, okay, I got my node. Very simple enough. Over here also I've written the same thing, so this is how you get it. Now there is something like count words that are starting with this. There's something like count words that are starting with. So what you'll do is node star equal to node equal to root as the initial stuff that you will do. And since you're requiring to count words that are starting with, can I again say you will simply iterate across this word? I can. Let's iterate across the word. And what I'll do is, if node contains key, then it's okay. That's absolutely okay. And what you'll do is, you'll go across to getting this word. And if it does not, there's the same thing. You'll say there does not exist anyone, so can you please return a 0? Again, perfect. But if you are returning the end, can I say you have to just return node, how many are there, which is get prefix, because you don't need end, you need how many are there. So get prefix will do that job. I think makes sense. Quite simple again. Now we will be doing the next one, which is get erase. Now in order to do the get erase, let's logically think what I am doing. I am initially, that's very obvious. This is kind of very obvious. The first thing we will always do is iterate across the string. So I've iterated across the string. Now what's my job? If the node contains the word I, then what I'll do is I will have to decrease it. So I will say, let's move to this guy. Yes, let's move to this guy, which is again this one. Let's move to this guy, which is node equal to node get of word I. Once I'm at the try, can I say reduce prefix? Yes, I can. But if I do not find it, that means this word does not exist and I can return. And once I'm at the end, can I say I have to also reduce the end, which is delete end? Or you'll be like reduce end. This is what I'll do, because I'll reduce the prefix. I'll go to the try of the word I, and then I'll reduce the prefix, and then I'll delete it. This is how it goes. The complexity, simple enough. Big O of n. Big O of the length of the word, big O of the length of whatever you are calling. Now there might be questions where you say that, but Striver, we can use map data structure. Yeah, you can use, but it will be tough because you have to store all the substrings. Whereas in try, the memory taken is very, very less. In map, the memory will be very, very high because you have to store every substring. Over here, you're not storing every substring. This we'll understand in deep in the next question that we will be doing. So guys, I hope you have understood the explanation as well as the code. The running and the accepted code is in the description below for C++ as well as Java, and the problem link is also there. So make sure you check them out. And yes, if you haven't checked out our SD sheet, what are you doing, man? You should definitely check our SD sheet, because a lot of people are using that and getting placed in a lot of product-based companies, and it's absolutely free. So make sure you check out the SD sheet as well. So guys, I hope you enjoyed this lecture, and with this I'll be wrapping up this video. And yeah, make sure you like this video. If you're new to this channel, please do consider subscribing. And yeah, with this I'll wrap up this. Bye bye, take care, see ya.
Whenever your heart is broken.